Algebra 1, Day 27. Today we're going to be talking about graphing systems of inequalities. So before we get started on that, what I want to do is I want to go ahead and first have us go through and just talk a little bit more about inequalities. Okay, so first thing to note about these guys, inequalities, they have these symbols. So they only have four symbols. And these are going to be either greater than, less than, greater than or equal to, less than or equal to. Now, how do I figure out which one is which? Well, these items always open towards whatever's bigger. If you use that, I guess, and kind of think in your mind about it, as I was taught when I was a kid, it's kind of like having a very not well drawn alligator, and their mouth is always opening towards whatever is big. Always. So wherever the mouth is facing open, that means that it is bigger. Okay. So, with that in mind, let's talk a little bit about this. So, there's a couple of different graphs that we can have with this. Okay, so here are the ones that are equations, okay? So I'm going to put equation, 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 okay? Now, with that, I'm going to graph each one of these. Okay, so for this first one, it's going to be shaded above and a solid line. Okay, here's my line, shaded above. This told me my line was solid. Okay, next one. No extra line, that means that this is a dashed line. And its y is greater, so that means I'm going to shade above. Okay, next one. Extra line, well, that just means, let me pick a really good color for this. Extra line means, excuse me. Extra line means solid. And I see it's y smaller than because it's opening towards the equation, shade under, down. Okay. Okay, next one. Again, here's a random line. Y. So I see here that this is y less than equation. No extra line. That means that this is going to be a dashed equation. And it's y smaller than, so I shade below. Now, in each one of these, we have solutions and not solutions. Okay. So here in orange, I'm going to go ahead and mark off solutions. Solutions can exist anywhere on a solid line, anywhere in a shaded region. They cannot exist on a dashed line. So that means I cannot say that it is a solution for us to be on this dashed line below. So only here these orange X's. Okay. Over here again, they can exist on a solid line. They can exist in a shaded area. Over here, they can exist in the shaded area, but they cannot exist on a dotted line. Okay. So now, what I want to do is I want to talk a little bit more about something else. So, sometimes you might see equations that look like this. There can also be variations in both of them, so that you have to shade it, make a dashed line, etc. Okay. So for these kind of lines, of course, whenever we graph them, see, I'm going to go ahead and create a new page. And let's get us a graph here. All right. So for this guy, let's say, for example, that I had x greater than or equal to positive 3. So I'm going to go ahead, I'm going to create my axes. So, of course, range, domain. Okay, so I got that. I'm going to look for x is equal to 3. So x is equal to 1, 2, 3. All right. So this is a point located at 3, 0. Now, is it not true that this is also x equals 3 at 3, 1? Yes. And at 3, 2, 3, 3, 3, 4, 3, 5, 3, negative 1, 3, negative 2, negative 3, negative 4, negative 5. All right. So I have a bunch of points, just like I would graph anything else. Now I go back and I look at this. This guy has an extra line. That means that this line should be solid. This one says x bigger than. So I'm going to look for the side that has bigger x's. That's going to be out here. So I would shade in this direction. So all of this would be shaded. Now, if they were asking me about solutions, any one of these guys on this line, because this is a solid line, and anywhere in this shaded region over here, I can pick any point I want. All right, let's do the same thing now with one of those Y graphs. Okay, so here is one of my axes. Okay, 5y is less than 2. Here's my range axis, domain axis. So my first step is always going to be, let's find this. So where's y equal to 2? Right there. And I ask myself, isn't it also equal to 2 out here? Yeah. Okay, so I'm just going to keep on drawing in points until I run out of graph here. Okay, so I got that. Now I have to ask myself, okay, is this a solid or a dashed line? I don't see an extra line, so I would say that this one is dashed. Now I look at it and I say, is it y smaller, y bigger? This is y smaller. So I would shade below all this region down here. Okay, if they ask me where are the solutions, anything inside of this shaded area, not on the dashed line. Now, another interesting point to note about this is that we can graph multiple of these guys onto one graph. Now, the interesting thing about that is same exact rules apply. So, if we are dealing with systems, meaning two equations at one time, it must be in both shaded areas or shaded area and solid line. Okay, same exact rules. So let me go ahead and just draw up an axis. Okay. I'm going to go ahead and draw out two random lines. So as you can see, this one's unshaded with a positive slope. Now I'm going to go ahead and I'm going to draw in another one. And I'll do this other one over here in a gray color. Actually make that a little bit bigger. Okay. I got that gray color. So for this one, I'm going to shade above. Okay. Now I'm not really paying attention to everything about this graph. What I'm doing instead is I'm looking at it and I say, all right, what area do they have in common? What do they have in common? So I look, okay, so anywhere that I see gray and red at the same time. So anywhere inside of this purple region, and of course extending beyond where my graph stops, is going to be a solution. So here, here, not there, because that dashed line is not part of the solution. It can be located, however, on this solid line. So again, I'm looking for where it's either in both shaded regions or a shaded region and on a solid line. That also means everywhere that I'm about to put a red X is not a solution. Anything out here, over here, right there, here, 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 here. All not solutions, okay? So, now back to these graphs up here. The way that you should graph these always is to pretend like they're y equals mx plus b and graph it just like a normal line and then decide if it is solid or dashed. And then shade up or down depending on if y is smaller or bigger. All right, so now that we understand how to do that, let's go ahead and get a jump start on our notes. So, graphing systems of inequalities means that you are graphing two inequalities on the same graph. Any points in the area shaded by both inequalities is considered a solution. Okay. So let's take a look at the symbols. I'm going to write in my y's over here just so it'll be easier to read. And this blue part would be some equation. We don't really care what it is. All right, first one, I don't see an extra line, so it is going to be dashed. All right, so no extra line here. I see y is bigger, shade up. Okay, I see here no extra line, it's going to be dashed. Y is smaller, shade down. I see here extra line, it's going to be solid. I also see y bigger, shade up. I see extra line, solid. I see y less than, shade down. Okay. All right, so let's go ahead and take a look at these. Here they gave us two separate equations so that they want us to go ahead and rearrange, do whatever, and go ahead and plot them on the graph. So first thing that I want to do whenever I'm dealing with this is I want to go ahead and pick one of the equations to start with. So I'll deal with the 8x plus 4y less than or equal to 12 over here, and the y plus 2 less than 1/2 x over there. All right, so first things first, let's look at this one. So I need to go ahead and make this look like y equals mx plus b. So I need to do exciting move. And my great divide. So here, symbol stays the same, no changes. Great divide. symbol does not change. And here's the first equation. So let me write that in. Y less than or equal to negative 2x plus 3. So my y-intercept is going to be positive 3, 0, 3. My slope is the number that is attached to x. I see that it has the extra line, so it's going to be solid. I see it's y smaller than, so it's going to be shaded below. All right, let's look at this guy over here. Y plus 2 less than 1/2 x. So I'm going to do exciting move, great divide. So I'm going to move this guy. And I'm good. So there's my equation. Let me write it in. Y less than 1/2 x minus 2. So my y-intercept is 0, negative 2. What is the slope? The number that's attached to x. Type of line, this is going to be dashed because it does not have the extra line. And shaded, y less than, shade below. Okay. So I'm going to go ahead and do this one in a different color just so we can differentiate a little bit better. Okay. Okay. So let's go ahead and deal with this one in red here. So this one is y less than or equal to negative 2x plus 3. So first thing, of course, is I'm going to identify where is my range, where is my domain. I'm going to take a look at this. I see that positive 3, so I'm going to look for it. Go ahead and plot that point. And now I'm going to go with my slope. M equals negative 2 over 1. So it's going to be 2 down, 1 to the right, 2 down, 1 to the right. I'm going to continue that pattern all the way down until I run out of graph. Then I'm going to go back to that original point in my y-axis. And I'm going to do the complete opposite. 2 up, 1 to the left. All right, so now I have that. Now I'm going to look at my inequality symbol. I see that it has the extra line here. So that means that this guy is going to be solid. Okay, so now I have my lines here. And I need to decide if I'm going to shade above or below. I see it's y less than. So I'm going to shade below. Better yet, let me go ahead and shade using the highlighter. So anything that's shaded in red is also part of the solution. Because this line is solid, anything on the line is part of its solution. Okay, so let's look at this one in blue. Y less than negative 1/2 x minus 2. Okay, so first things first, I need a graph that's negative 2, so I'm looking at my y-axis, negative 2. My slope is 1 over 2. 1 up, 2 to the right. Opposite direction, 1 down, 2 to the left. So I'm going to go 1 up, 1 to the right. 1 up, 2 to the right. Opposite direction, I'm going to start back at my y-intercept, and I'm going to go 1 down, 2 to the left. All right, ran out of graph. Now I'm going to ask myself, solid or dashed? Well, I don't see the extra line here, so I know that this is going to be a dashed line. So I'm going to go ahead and complete that in. Okay, got that. Okay, so I got my line here. And now I have to ask myself, shade up or shade down? I see it's y less than, which is going to mean shade down. Let me go ahead and get that. Everywhere that's below this line, I'm going to shade. All right, so now I'm looking at this. The areas that are blue shade only are solutions for only the blue equation. The area that is red shade or on the red solid line are solutions for the red equation only. The area that is shaded where the blue and the red overlap, creating purple, in addition to the part of the line that has the solid line here, because that is inside of a blue shaded area and a red shaded area, are part of the solution for both of them. So that means that I have solutions all up and down here, as well as all inside of here. Okay? So now I'm going to look at the 4 example solutions they gave us. 0, 0, 5, -1, 0, -3, -2, -3. So let me choose a better color. I'm going to look for 0, 0. That's not a solution. 5, -1. Nope, that's not even in the purple area. 0, -3. Yes, that is. Okay, so that's 1. -2, -3. That's right on the blue shaded area. That's right on the border of the blue shaded area. It's within the red shaded area, but it's on that dashed line, so that's not 1. So the only one of those that's an actual solution is 0, -3. All right, so I want you guys to go ahead and get started on this, and I will see you next time.